Dear students, today we will discuss about how to compress audios and videos. So we will be discussing two major popular formats. One is MPEG and another is MP3. The MPEG format, known as that was developed by Motion Picture Expert Group, that was led by International Standard Organization ISO, and it has various standards and various ways to compress the videos, the motion picture, and it uses different technologies for different purposes. One of the purpose, for example, could be to compress the HD TV videos. So you know that high definition TV have a proper medium, transmission medium, from one end to another end. So there it applies different kind of methodology to compress the motion picture. However, for video conferencing, it uses all of the available infrastructure that might not be very hi-fi to support. So therefore, it uses another version to compress such videos over the video conferencing system. So MPEG techniques are considering videos as a sequence of picture. So you know that a video is actually a sequence of pictures. So for example, if you take pictures, 100 pictures in 1 second, so those pictures, if connected together, that become a video. So you are not taking 100, you are taking many more. So some of the pictures known as iframes are encoded entirely by this MPEG, whereas pictures between iframes are encoded using relative encoding scheme, which we already discussed, and distinction from the previous images only stored. Then there is another format that is well-known format known as MP3. You might have already listened or heard about it, and you might have used MP3. That is developed within the MPEG, and that is called MP3 is MPEG layer number 3. And how MP3 works, MP3 again take advantage of human ear. So it tried to trick our human ear to make the reductions in the size. For example, one of the way that it used is temporal masking. So you know, for a short period after a loud sound, we cannot hear a soft sound. So it tries to reduce or eliminate such sounds to reduce the size of the audio. Then it uses frequency masking. Sound at one frequency tend to mask softer sounds at nearby frequencies. So it already tries to eliminate such sounds which are available at nearby frequencies. And then with these techniques of MPEG and MP3, nowadays cameras can store, for example, 1 hour of video in 128 megabytes. So you already learned in previous modules that storing one video of 1 second, even one audio of high definition in 1 second, you need million of bits. So 1 megabyte a bit is required. However, with such a compression technology, we have achieved that we can store 1 hour video audio to 128 megabits bytes. And then there are 400 popular songs that could be stored on a single gigabyte. And sometimes the goal is not only to reduce the size. There is another goal or objective of these kind of techniques of MPEG and MP3, that they make an encoding that allow data transmission faster over the network and to when communicating with other devices. So you know that normally we measure the data transmission in bits per second. So for example, there is a kbps, which is 1000 bits per second normally. Then mbps 1 million bits, and gbps is 1 billion bits. So MPEG successfully can relate on communication paths having 40 Mbps transfer rate. So if there is a lesser amount of transfer rate available on a communication medium, then MPEG cannot be relayed or cannot be watched to the other device. Similarly, MP3 do not require transfer rate of more than 64 kbps. So this means that the advantage is not only they are compressing the size, they are also making such technologies which can be utilized and used in our daily life by considering the limitations of communication medium in our real life. So if we summarize today's module, we have learned how to compress audios and videos. We have discussed MPEG and MP3 formats, and we have seen how the space is compacted and how the transfer rate has been made perfect by these techniques to actually being used in the real environment.